Hi, this is Mr. Best. Welcome to our next unit on solving equations. We'll learn how to solve radical equations and inequalities today. We'll learn how to solve rational equations and inequalities, and we'll also learn how to solve absolute value equations and inequalities. This stuff is not technically a unit in our book, but it is in the appendix in the back, so that's what the B.3 and the B.4 represent. So if you need more information, that's where you'll need to go. So we're going to learn about solving radical equations and inequalities today, and different variations of them as well. So you can see kind of off to the side here the kind of steps to follow, but just like any equation, you work backwards. You undo the problem so that you can solve for the variable. So with square roots and radicals, whatever the index is what you're going to do to both sides to undo that problem. So let's just go ahead and just look at kind of a basic one to start off with. The first step is we always need to make sure that we isolate the radical on one side. So here's your radical. It doesn't matter what's inside of it, but is that by itself, or is there anything with it on the left hand side? And in this case, this one is isolated. So step one is done. Step 2 is to square both sides to eliminate the radical. Well, it's not just a square, it depends on what the index is. So since this is a square root, there's a 2 right there, not written. It's understood that it's a 2. So on this one, to undo a square root, you will square that side, which means you'll square the other side. So when you undo a square root, you square both sides, and that cancels it out. And so that leaves you with just x plus 4 is equal to 3 squared, which is 9. And then step 3, repeat steps 1 and 2 if necessary. That's if we have multiple radicals. In this one we just have one, so we don't have to worry about that. So we're on to step 4, solve for x. Subtract 4 to both sides. And that leaves you with x equals 5. Now, step 5 is to check for what we call extraneous solutions. I'll give you a better idea as to when you really need to check, but it's not a bad idea to check really anytime you're solving a radical equation. You don't necessarily have to show the check, but you can see that 5 plus 4 do that again. 5 plus 4 is supposed to be equal to 3. The square of 5 plus 4 is supposed to be equal to 3, so that's the square root of 9. So you can see that x equals 5 is our solution. And there you go. So we only have one solution to this equation. So that's the general idea on how to solve. Let's look at a couple more here. So on the next one, we have one radical. You can see that this one is not isolated. This part needs to be by itself, and we have some other stuff here that we need to get rid of. So that's what we're going to focus on. So the first thing is to subtract the 4, but we're still left with the negative square root of x plus 6 is equal to just the x, and now we can divide by negative 1 to get the square root of x plus 6 is equal to the opposite of x. So step 1 is done. We've isolated. Step 2 is to square both sides, or depending on what the index is. Once again, this one is a square root, so we will square both sides. You can now see on the right hand side we're actually squaring a variable, which makes a difference. So we have x plus 6 is equal to negative x times negative x, which is x squared. Now, the first time when we had, it was linear, so in terms of solving it relatively easily. This one's a quadratic, so how do we solve a quadratic? Well, we set it equal to 0, so I'm going to subtract the x and subtract the 6 and set it equal to 0, and then you're going to solve this quadratic. I would first check for factoring. If it doesn't factor easily, then I'm going to possibly look at completing the square of the quadratic formula. So it looks like we will get x equals 3 and x equals negative 2. Now these are possible solutions. Step 5 is to check for that extraneous solution. Well, we know that up here, once it's isolated, that the square root of a number cannot equal a negative value. So there's a possibility we have what's called extraneous solution. So we're going to check to see if either one of these are extraneous solutions. So you can plug these back in. So we're going to check if 4 minus the square root of 3 plus 6 is equal to 3 plus 4. So this would be 4 minus the square root of 9 is equal to 7. 4 minus 3 is equal to 7. And so right there you can see that 1 is not equal to 7. So therefore x equals 3 is not a solution. It does not satisfy the equation. Okay, now let's go ahead and check the second one. 4 minus negative 2 plus 6 is equal to negative 2 plus 4. 4 minus the square root of 4 is equal to 2. 4 minus 2. So 2 is equal to 2, which works. So our only answer is x is equal to negative 2. So once again, that creates what we call an extraneous solution. It creates a solution that we thought was possibly a solution, but once we checked, we realized it was not. So radical equations, just make sure you guys are checking your solutions, especially when it's isolated, it's equal to that variable. Okay. Alright, let's go ahead and take a look at the next one here. We have to isolate once again, so we'll subtract the 4. 2 is equal to negative the cube root of x plus 9. Divide by negative 1. Negative 2 is equal to, is equal to the cube root of x plus 9. Now, if you take a look at this, when the cube root is equal to negative 2, some of you might think that that's not possible, but with the cube root you can get an output of a negative. With a square root you can't. So if this was the square root is equal to negative 2, it'd be no solution. But on this one, it's okay. To undo the problem, we want to raise it to the third power because it is a cube root. Negative 2 to the third is negative 8. And then you'll subtract 9 and get x equals negative 17. And once again, to plug that back in and check, we get 6 equals 4 minus the cube root of negative 17 plus 9. So 6 is equal to 4 minus the cube root of negative 8. 6 is equal to 4 minus and then the cube root of negative 8 is negative 2, so 6 is equal to 6 checks, so x equals negative 17 is your solution. So in terms of solving, once again, you're undoing the problem just like you learned how to undo the problems when you're doing linear equations and things like that. You got to isolate, get rid of the radical, and then solve and then check your solutions. So the last equation that we're going to look at is one that has 2 square roots on it. So if you go back to your steps, you did notice that the third step was to repeat steps 1 and 2 if necessary. So I'm going to tell you, leave some space on your notes to go through into this one. This is going to take a little bit of extra time because we have to do it twice. So the first thing is to isolate one of the radicals. So what we can do is take this and add this square root to this side. So we will have the square root of x plus 1 is equal to 1 plus the square root of 2x minus 12. Okay, So the next thing is we know that the index is 2, so we will square both sides. And when we square this side, it cancels. So you're just left with x plus 1, which is nice. But on the other one, this is 1 plus the square root of 2x minus 12 times itself. So this is a binomial times another binomial. So we'll use our distributive property. 1 times 1 is 1, plus 1 times the square root of 2x minus 12. And then we'll get 1 times the square root of 2x minus 12 again. And then the square root times the square root. Since they're the same, we're going to cancel each other out, and it'll be plus 2x minus 12. So now that we've gotten rid of one of the radicals, we're going to have to do the same thing. We're going to have to isolate the other radical. So let's simplify the right-hand side. We've got x plus 1 is equal to 1 and negative 12. That'd be negative 11 plus 2x. And then the square root of 2x minus 12 plus the square root of 2x minus 12. There's 2 of them, so that's plus square root of 2x minus 12. And now we need to isolate. So we're going to add the 11 and subtract. And subtract 2x. That'll leave us with negative x plus 12 is equal to 2 times the square root of 2x minus 12. Now, even though the square root is not completely isolated, if we divide by 2, we're going to create fractions here. So since it is 2 times the square root, I can leave it there. So the index is 2, so we're going to go ahead and square both sides. So it's a binomial, so negative x times negative x is x squared. Our middle term will be negative 12 and negative 12, so that's negative 24x, and then plus 144 is equal to 2 squared is 4, and then the radical cancels out. So we're going to continue to simplify here. We get x squared minus 24x plus 144 is equal to 8x minus 48, and then we will go ahead and subtract 8x and add 48 to both sides. So we'll kind of move our way back up here. That'll leave us with x squared minus 32x plus 144 and 48 would be 192 is equal to 0. So we need to solve that quadratic. How are we going to solve that quadratic? Well, you know, unless you guys know factors of 192 that give you 32, then we're going to have to possibly look at completing the square of the quadratic formula. Let me see maybe if I can come up with, if I check a couple factors for the 192 that give you 32. Let's see. What about, that'll be 28, so that won't work. Just trying to figure out if there was a factor or not. I'm not seeing it right now, but that doesn't mean it doesn't exist. I actually think I just found it, 8 and 24. So this would be x minus 8, x minus 24. And if we couldn't figure that out, we could have just done the quadratic formula completing the square. Either way would have been fine. X is equal to 8 and x is equal to 24. So you can see when you have two radicals that don't isolate, it takes a little bit of time to get through and potentially solving a quadratic. Now we got two solutions. We actually do need to go back and check to see if these work. So we have the square root of 8 plus 1 minus 2 times 8 minus 12 is equal to 1. So that would be the square root of 9 minus 16 minus 12 is 4. So this would be 3 minus 2 is equal to 1. And this one looks like it will work. So 1 is equal to 1, so that's good. And then if we plug in 24, we'll get 24 plus 1 minus the square root of 2 times 24 minus 12 is equal to 1, so this will be the square root of 25, and 48 minus 12 would be 36, so we have 5 minus 6, close, but not going to work, so negative 1 does not equal 1, so 24 is out, and our only solution is x equals 8. So that'll be your longest solving equation problem that you have. Okay, so we've kind of gone through the entire process. Some that are a little bit easier, don't take as many steps, just solving linear. Others where you're potentially solving quadratics, checking your answers, and then another one where you're doing a cube root instead of a square root. We could do fourth roots. Whatever the index is what you raise to the power. And then the last one we did was multi-step, really going through the entire process, checking and making sure that your answers work. So in terms of solving equations, that's all I'm going to talk about today on that. The last thing that we're going to do is solve a radical inequality. The biggest thing is what you see is you're going to solve the same way that you solve the equation. You're going to isolate, identify the index, raise both sides to that to cancel them out, and that'll leave you with 6x minus 5 is equal to 16. Add 5 to both sides. Divide by 6. Reduce your fraction by a factor of 3. And you get x is 7/2. Now for some reason, I wrote equal to all the way down, but it would be less than, and then if you divide by negative, you switch the sign. So we get x is less than 7/2. Now, it'd be nice if that was the end result, but for some reason up on top I say don't forget to check your domain. So if we graph this on a number line just to kind of get the visual, at 7/2 or 3.5, we would be talking about all these values. Well, potentially that's true, but we also know that the square root, we cannot take the square root of a negative. So if that causes a problem, then we need to fix it. And that's why I have up here to check the domain. So we need to say that 6x minus 5 is what? What must this value underneath the square root be? Alright, it has to be, because we can only take the square root of positive numbers and 0, it has to be greater than or equal to 0. That has nothing to do with this sign. Nothing to do with that sign. We are saying that underneath that square root, it has to be greater than or equal to 0. We cannot take the square root of 0. So don't make any misconceptions that that has something to do with our inequality. It doesn't. It's greater than or equal to 0 based on your domain. So if you add 5, you get greater than or equal to 5. Divide by 6, you get greater than or equal to 5/6. So 5/6 is somewhere over here. Okay, and we want values that are greater than or equal to that. So for example, if we plug in 0, we would get -5, the square root of -5. That's not part of our domain. So the only values that we want to include as solutions are all these values between 5, 6, and 3.5. So our solution at the very end is x is greater than or equal to 5/6 and less than or equal to 7/2. And so you must check your domain, and not just check it, you've got to be able to solve for your domain. And this is an AND statement, because both things must be true. Alright, and so that is it. But just before I let you kind of go here, one thing to think about also is if I give you the cube root of a number, do we have the same domain restriction? Do we have restrictions for our domain when we're dealing with cube roots? What is our domain for cube roots? It's all real numbers. So you don't have restrictions on cube roots, or not even cube roots, but odd roots. Odd roots are always going to give you values that are all real numbers. If you have an even index, then whatever's underneath here, okay, no matter what this is, whatever's underneath there, that expression must be greater than or equal to 0. So your domain would be all values greater than or equal to. Okay, now that's for your parent function. So once you plug that in and set it up over here, you can actually solve for what those x values are. Okay, we can discuss that a little bit more in class as well. So your homework is going to be a worksheet, and I will give you that tomorrow. Thanks.